Okay, good morning. Welcome back to Form 4 Biology class with Sundram. So we continue our journey in Chapter 4. So Chapter 4 is biochemicals. Under biochemicals, we are done with carbohydrate. We are done with lipid and protein in the last class. And way before that, we already done water also. So the last explanation to complete Chapter 4 is nucleic acid. So that's what we're going to do today. So today's class is all about nucleic acid. Now, in terms of nucleic acid, the explanation here is above average, not both actually. Above average in the sense there are a lot of names for you to remember, and most of the names are not easy names. There are a few names that are actually hard to remember. That is one. Another one is in terms of the structure of the nucleic acid is understandable, explainable. Structure explainable. But when it comes to function, there are a few terms in the textbook which we need to explain, and that explanation is quite a complex explanation. The thing here is, it's in the textbook. Because it's in the textbook, we can't skip. Anything in the textbook can become a question for exam. And it looks like the people who are setting the question, they know which are the parts that students normally don't read. For example, just a gentle reminder, chapter 6 is already online. Please watch it. We won't be doing chapter 6 in live class. You have to watch the recording. And like for example, people setting the question, they know students normally don't like chapter 6. Either they don't read the chapter 6, or even they skip chapter 6. And people setting the question, they know. So the last 4 years SPM question, 3 of the years we have questions related to that chapter. And last year, they made it part of compulsory essay. They know. So somehow they know how to read the student's mind. Whichever that you don't read, that's the one they're going to ask. So whichever you don't read, in that category will be this one also. Chances are high. This will also come under that category where students might not read this. They might feel this is a bit complex or what. But as I mentioned, if it's in the textbook, it can be a question. It can even be a compulsory essay question. This compulsory essay question can make or break the paper. If you didn't do well in the compulsory question, you can forget your A plus already. Sometimes even A also cannot get if you didn't do well in the compulsory essay. The marks are same. Just that, other questions, at least the other essay, you have option of choosing which one you like. But compulsory is compulsory, have to answer. And if it comes out something that you didn't like or you didn't cover, then it's going to drag down the paper. Okay, so let's start with the nucleic acid explanation. Give me a minute. Okay, let's start with nucleic acid explanation. It is going to be a bit complex, but it's in the syllabus. Okay, so in terms of nucleic acid, so nucleic acid, this famous picture that you have at the side here is supposed to be DNA. DNA is also famously known as a double helix. You can see one helix in here. You can see another helix. DNA is supposed to be double helix. But in terms of explanation, every single explanation we had in this chapter except for water, for carbohydrate, for lipid, and for protein, the first explanation is the monomer, the basic unit. When we start carbohydrate, we start with monosaccharide. When we start protein, we start with amino acid. When we start lipid, we start with glycerol and fatty acid. So what is the monomer for nucleic acid? Nucleic acid, there is two types. There is RNA and also DNA. Both of them, you must know the full name. RNA is ribonucleic acid, while DNA is deoxyribonucleic acid. A point to note, both of them have the name nucleic acid. The one I've given in green is the nucleic acid. Both of them, there is two types of nucleic acid. Both of them have the name nucleic acid. So in the short form, the Na is for nucleic acid. Only the front part is different. What is the difference between these two? Later we'll explain. So there is two types of nucleic acid. There is DNA and RNA. Both DNA and RNA consist of polynucleotide. The word poly means many. Many what? Many nucleotides. So both DNA and RNA consist of many nucleotide chains. So that means to make many nucleotides, you need to have first one nucleotide. So the nucleotide is the basic unit or the monomer of nucleic acid. So that is our first 3-4 marks explanation. First point is the basic unit, the monomer of nucleic acid is nucleotide. The name nucleotide is 1 mark. Remaining 2-3 marks is the structure of the nucleotide. How does a nucleotide looks like? Each nucleotide will have 3 components. When we draw the nucleotide, the first component we draw is a pentagon in the center. The pentagon represents a pentose sugar. And most of the time, the students will think the name pentose sugar because they have pentagon shape. The word pentose sugar, not because they have pentagon shape, because they have 5 carbon. By right, inside this structure, there is 5 carbon. That's why we call pentose sugar. Penta means 5. So in the center, we have pentose sugar. The pentose sugar is connected to what we call as a phosphate group. This is supposed to be a phosphate group. The same phosphate group that previously you learned under ATP. I did spend some time explaining to you what is ATP under active transport. Adenosine linked to 1 phosphate, 2nd phosphate, 3rd phosphate. Each of the phosphate is same with this. So in the nucleotide, a pentose sugar is linked to a phosphate group. And the same pentose sugar is also linked to another molecule known as nitrogenous base. Now, why do I have an A in here? Why I have a P is quite obvious because it's phosphate group. Why do I have an A when the name is nitrogenous base? After this, we'll explain. Now, this is one nucleotide, the basic unit of nucleic acid. There have been a few past year questions and also trial paper. They asked to draw nucleotide. So drawing of nucleotide is part of syllabus. After this, we'll draw the nucleotide. And by right your notes, if you check the nucleic acid explanation, right after the explanation, there should be an empty page. That empty page is for us to draw nucleotide and also for us to draw DNA. You're going to draw 2 diagrams today. All of these diagrams are part of syllabus, have come out in exam before. This is one nucleotide. A few points to note is, when you draw this nucleotide after this, make sure the line, this line represents the covalent bond. This line represents covalent bond. The line must come from the corner. That means you can't draw, let's say you can't draw phosphate group like this. Coming from here, from the middle is from any other area, as long as they are not from the point. It must come from the point. If it's coming from any other position, wrong. Same goes with nitrogenous base. They must come from this point. It cannot come from here. It cannot come from here. So make sure it comes from the corner. There is a reason why. Later when you learn chemistry, you're going to learn this is where you have all the carbon atom. The corners is where you have the carbon atom. So the link must be to the carbon atom, meaning it must be to the corner in here. So this is how one nucleotide looks like. Sorry, give me 1 minute. In case you're wondering, the picture you're looking at supposed to have a snake. See whether you can find the snake or not later. Okay, so this is one nucleotide, basic unit monomer of nucleic acid. And in terms of phosphate group, I thought it's an owl. You can see an owl in the picture. No, not an owl. It's on the forest floor. Yeah, could be owl also. Maybe the owl is walking on the forest floor. It's supposed to be a snake. Highly camouflaged and highly poisonous snake. Okay. In terms of phosphate group, there's only one type. So that means phosphate group is phosphate group, no further explanation. When it comes to pentose sugar, there is two types of pentose sugar. When it comes to nitrogenous base, there is five different types of nitrogenous base. And this is where the problem is, because nitrogenous base got 5 different types and they have some weird names, but they're part of syllabus. Okay, so we start with nitrogenous base. Nitrogenous base got 5 different types. These are the names you need to remember. If you put a symbol A, it represents something called as adenine. So adenine is one of the nitrogenous base. Luckily, blessing in disguise. Early morning, still early in the day, you're still fresh, haven't gone for other tuition, I hope. So your mind is still fresh, should be able to absorb all of this information. If you do it later in the evening, you're a bit tired. All of these are quite heavy explanation. Today's class is going to be heavy. It's a blessing in a way, because early morning, you're still fresh. Not early morning, early in the day. You're still fresh. Adenine. The next one is called as guanine. The third one is called as thymine. The fourth one is called as cytosine. And the last one is supposed to be uracil. As I mentioned earlier, it's part of the syllabus, must know the name. Okay, and what I have done here is I'm using, if you draw this nitrogenous base, this is how we draw in Form 6 in A level in matriculation. Each one of them do have a unique shape. Like these two are supposed to be longer. These three are supposed to be shorter. This is supposed to be pointed. This should be rounded, pointed inwards, rounded inwards. This is for Form 6. I'm showing you this way. But when you draw this later, you just make it into a rectangle. Another thing here. This is uracil. Out of these 5, thymine, if you see, thymine and uracil has the same shape. It's like pointed inwards, just the symbol only changes, because thymine is only found in DNA, whereas uracil is only found in RNA. Adenine, guanine, cytosine, you can find in DNA and RNA. The fourth one, DNA will have thymine, uracil will have, the RNA will have uracil. Now, I'm drawing it this way. There is a reason why we draw it this way, but for Form 5 level, all of them, you just draw a rectangle like what you see here. You just draw a rectangle is fine. You don't have to draw them specific like what I have drawn here, like pointer, rounded, all from 6 level. There is a reason why we draw pointer, rounded. After this, we'll explain. At the moment, for your level, if you're drawing a nucleotide, you just draw a rectangle shape is more than enough. So these are the 5 names you need to know in terms of nitrogenous base. Can't skip all of these names, you need to know. Number 1. Number 2, in terms of pentose sugar. Pentose sugar, we have 2 different types. If it's a nucleotide, it's a pentose sugar. If it's a nucleotide, it's a pentose sugar. But pentose sugar, we have 2 types. One of them is called as ribose. Another one is called as deoxyribose. And actually, why is it called deoxyribose? If you refer to your notes, the picture should have a clue in why you call it deoxyribose. Let me check whether I'm using the same picture. Okay, now refer to your notes. Okay, the note that you have, you should have a picture of DNA. Okay, this one. Okay, now you see here, if you look at this part of the diagram, this is ribose. And if you see this here, you have OH, hydroxyl group. Whereas when it's deoxyribose, you see there's only hydrogen here. So what's missing? What's missing is this one oxygen in here is missing. So the oxygen that used to be here has already been removed. That oxygen no more. That's the meaning of the word deoxy. Deoxy means the oxygen has been removed. I repeat, thank you. I repeat, you don't have to know the reason. In the actual exam, you only need to know the name. Ribose, deoxyribose. You just need to know the name. But as already mentioned many times, I don't like the students to memorize the name. If you understand the name, it's easier for you to answer the question. So you just remember the word ribose. One type of pentose sugar is ribose. If you remove the oxygen from the ribose, one oxygen from the ribose is called as deoxy. The word de means remove. Dehydration, remove water. Deforestation, remove the trees from the forest. De means remove. Deoxy means remove the oxygen. Which oxygen? This oxygen already removed, you don't find them here. That's the meaning of the word deoxy. So you need to remember the word ribose, one type of pentose sugar. If you remove the oxygen, it becomes deoxyribose. Naming RNA and DNA. Naming the RNA and DNA is based on the sugar they have. If it's nucleic acid, the name of the sugar, pentose sugar. Nucleic acid. If it's DNA, just take this. If it's RNA, just take this ribose, place it at the front of nucleic acid. Take this ribose, put it at the front of nucleic acid. You get ribonucleic acid. If it's a DNA, take this deoxyribose, put it at the front of nucleic acid. Deoxyribonucleic acid. That is how you name a DNA and RNA. If it's pentose sugar, nucleotide. If you're drawing a nucleotide, if you label as nucleotide, that means this is a pentose sugar. General name. Nucleotide has pentose sugar. But if you know the name of the sugar, let's say the sugar is ribose. Everything after this, you add the word ribo at the front. If it's pentose sugar, nucleotide. If you know it's ribose, just make it into ribonucleotide. That's the monomer for RNA, ribonucleotide. Nucleotide is the monomer for nucleic acid. Ribonucleotide is monomer for ribonucleic acid. Ribonucleic acid, short form is RNA. The R is basically ribo. If you realize, the monomer is nucleotide. The monomer is nucleotide. Sorry, my writing is like this. Nucleotide. Since my writing is like this, what I need to do is I need to type it out. 1 minute. Okay. Okay. We have nucleotide. We have nucleic acid. Both of this, what you need to do is, you just take this ribo, bring it to the front, you get ribonucleotide. That's the monomer, ribonucleotide. What is the polymer? Polymer is at the word ribo in front. Ribonucleic acid. Ribonucleic acid is short form is RNA. Same thing. After this, what you're going to do, let me just transfer this. Let's just put it here. Now, this is for RNA. If it's a DNA, the name of the sugar is deoxyribose. Because the name of the sugar is deoxyribose, take the deoxyribo, place it at the front. The monomer is deoxyribonucleotide. Just take this deoxyribo, place it at the front. You get deoxyribonucleotide is the monomer. You take this, you place it at the front of the nucleic acid, you get the polymer. The polymer is deoxyribonucleic acid. Short form will be DNA. So that means to know the name, you need to know the name of the sugar. Ribose, deoxyribose. Using the name of the sugar, you can get the basic unit. This is the basic unit. You can also get the polymer name. The polymer full name is ribonucleic acid. Deoxyribonucleic acid. All of this information already in your notes. At the moment, we are done with nucleotide. After you know the structure of nucleotide, we need to explain polynucleotide, RNA and DNA. At the moment, I've only covered I've only covered nucleotide, which is the basic unit of nucleic acid. So what we need to do now is, we go back to the notes. We need to draw we need to draw and label a nucleotide. Yes, your notes have all of this, but you didn't draw this. All of this was already there in the notes. Exam time, they can ask, they have asked structure question, compulsory question. Draw and label a nucleotide. So I've already done, to save time, I've already drawn, I think not in these notes, the other notes, I've already drawn the nucleotides. So you need to copy this. Taking a picture of this, is going to make your computer or your handphone to memorize the picture, not your brain. You need to use your senses. You use the sensors of the camera in your phone remembers, because you're using the sensors in your phone, not your senses. Your senses is your hand, your eyesight, your hearing. You hear me explaining, you see the diagram, and you use your hand, your sense of touch to draw the diagram. Only then you remember, your brain remembers. If you're using another device sensors, that sensor will remember, you won't remember. Okay, so this is how I have drawn nucleotides. So you need to draw this in your notes. By write your notes, there is one empty page under the nucleic acid. So the page, let's say the page is like this. Use 1/3 of the page to draw this diagram. 1/3 of the page. So 1/3 used for nucleotide. 2/3 after this we'll draw the DNA. Here you're going to draw DNA. Here you're going to draw nucleotide. So, or if you feel you want to attach another paper can, I gave one empty page. 1/3 for nucleotide. 2/3 is for us to draw DNA. At the moment, this is the nucleotide. At the moment, this is the nucleotide. Copy this. Okay, so this is just a summary of what you already learned, which is, this is the pentose sugar. The pentose sugar may be ribose, maybe deoxyribose. Based on the name of the pentose sugar, you can get the name of the nucleotide. There's a mistake here. So this is ribonucleotide. This is deoxyribonucleotide. Okay. So in terms of nitrogenous bases, all of them you just draw rectangle shape. The alphabet inside represents the type of nitrogenous bases. Adenine, guanine, cytosine you can find in DNA and also RNA. Thymine is only found in DNA, whereas uracil is only found in RNA. Phosphate group, there's only one type. Nucleotide is the basic unit of nucleic acid. Drawings and labels are part of syllabus. If you're drawing this in exam, you just need to choose for nitrogenous base. You actually take note. If you're drawing in exam, all of this that you have here and all of this, no need. You just, sorry. All of this, no need. All of this, no need. What remains is what you need to draw for exam. So since you're drawing the nucleotide, what I'm doing is I'm making it a compact diagram. Whatever I taught you so far, it's already in this diagram. Everything that I explained to you so far is already in this diagram. Once you're done, raise your hand. Manus. Now, if you immediately raise hand, then we can know already you didn't draw. You just took a photo of it, most probably. Okay, in case some of you wondering how to draw a nucleotide, okay, in case you're wondering, you always start with the pentose sugar. Or easy way to draw a nucleotide is this. You just draw a slanted line like this. Just draw a slanted line like this. Use this line to create the pentose sugar. Use this line to create the pentose sugar. And the rest is just easy lah. So you put a phosphate group in here. And here you need to have another line extending horizontally. Just make a cube in here. Rectangle, sorry. So the rectangle will become maybe adenine, guanine, whichever. Normally we write, because you're drawing a nucleotide, it must fit both RNA and DNA. Because by right, thymine is only in DNA, uracil only in RNA. So what you label here depends on what you're drawing. If you're drawing a nucleotide, here you can use adenine, guanine, cytosine. If you're drawing a nucleotide, avoid thymine, uracil, because thymine, uracil is only found on one of it. Adenine, guanine, cytosine, you can find in both. Most of the time, my diagram, I'll use adenine. So you're free to use guanine and cytosine. But let's say the question is about DNA. They ask you to draw a nucleotide for a DNA. If it's a DNA, you must use thymine. If it's a RNA, you must use uracil. Later, I'll show you. And actually, I think in my diagram earlier, check. Yeah, here you see, what I meant by that is, I'm using uracil because I'm using this whole diagram for RNA. So I'm showing you RNA can only have uracil. This is for DNA. So for DNA, I'm using thymine. So if you're making it specific, if you're showing deoxyribonucleotide, you need to have thymine. If you are showing ribonucleotide, you must have uracil because only ribonucleotide have uracil. Only deoxyribonucleotide have thymine. But if you're drawing a nucleotide, not this, general, if you're drawing a nucleotide, so you can put here adenine, guanine, or cytosine. So the drawing you're drawing now is a general diagram. A general diagram should have adenine, guanine, cytosine. I repeat, it's very easy to draw. Just have a slanted line. Use that line to form the pentose sugar. And the rest is standard. Okay, so this is the phosphate group. Here maybe adenine, and by right, make sure all the lines are connected. You have a gap like this, that is not accepted. Make sure the line is connected. Okay, this is a nucleotide. So the labels is what you have in here. Okay, quickly draw. Once you are done, raise your hand. I take my brunch, lunch and breakfast and lunch. Exam question, structure question. They'll ask you to draw, and most of the time they'll ask you to draw. Sometimes they ask you to draw and label. You check the question. But normally, even if they didn't ask us to label also, we'll make it a point we label. Dia tanya ke tak tanya, kita label. But by right SPM, the question is precise. If they want label, they'll ask you label. If they don't want, they don't ask. You just follow the instruction. But normally what we do, they ask or don't ask to label, we label the diagram most of the time. But I repeat, all of these are extra information. What you have here and what you have here is extra. If you're drawing for exam, what you have there is enough. But check the question whether they're asking you for nucleotide or they're asking you for deoxyribonucleotide or ribonucleotide. Draw accordingly. Whether you need to, what is the nitrogenous base, what is the pentose sugar, depends on what nucleotide you are drawing. Check the question. Okay, done. This is the first drawing, which is supposed to be easy. The next drawing is supposed to be a bit complicated. Okay, so I'm waiting for Tanusha. Done? Okay. Now, are you getting some messages? Pon Anita's handphone is hacked. Are you getting any messages in the WhatsApp group, PTF WhatsApp group, that Pon Anita's handphone is hacked? Don't click on the link. Are you getting any messages in the groups? PTF is sending you Pon Anita's later you check that it's the PTF is sending you a message that Pon Anita's handphone is hacked. Not yet. Okay. Later you'll be getting some messages. Now, to avoid all of this, use iPhone. This hacking are only for people who use Android. People who use iPhone won't have all of this problem. Our iPhone ecosystem is secure. Rarely people hack. Android is the one. Like I use iPhone. My wife use Android. For some reason, girls like Android. Because only Android camera, you are plump also, the Android camera will make you slim. iPhone will show you what is there. They don't adjust the camera. So most of the people don't like Android iPhone. I mean, girls don't like iPhone because it shows what is exactly in you. You have pimples, it shows the pimple. But you take Android, the pimple also becomes smaller, or maybe the pimple disappear altogether. It gives you a false identity, and people love false identity. So anyway, if you don't want to be hacked, use iPhone. Android is bound to be hacked if you install some unnecessary software, and this is what happens. Android, iPhone is safe. Okay. So anyway, that's besides what you're learning today. At the moment, we are done with nucleotide. So by right, everything you see here, by now you should know, already draw. So basic unit done. We use the basic unit to form the polymer, the nucleic acid. Nucleic acid, there is two types. There is RNA and DNA. By now you should know the name ribonucleic acid because they have ribose sugar. They can only have adenine, guanine, cytosine, uracil. Cannot have thymine. So at the moment, this is a nucleotide. If you draw a nucleic acid, this is a nucleotide. But you're going to draw ribonucleic acid. You need to make the pentose sugar ribose. Because the pentose sugar is ribose, this whole thing is now ribonucleotide. Lucase nucleic acid, nucleotide. Lucase ribonucleic acid is ribonucleotide. Now this is one. If I have a few more ribonucleotide, we just arrange them in a row, one on top of another. When we have a few nucleotides in a sequence, this part here, a link will form. There is a name for this link, luckily not in the syllabus. So originally we had 1, 2, 3. We had 3 ribonucleotides. When they are facing one another, condensation will happen. They form the link. They form the link. They form the link. So now, earlier you had one nucleotide. Now you have many nucleotides linked to one another. It becomes a polynucleotide. And because the basic unit is ribonucleotide, this is one chain. That one chain is called as ribonucleic acid. It's a single chain. It's ribonucleic acid. This is how you draw RNA. So I've already mentioned many times, the name of the sugar is ribose. You can have adenine, guanine, cytosine, uracil. So I have adenine, I have uracil, I have cytosine. Actually, a better diagram will have one more nucleotide. So we have 1, 2, 3. A better diagram will have one more nucleotide. That nucleotide should have what nitrogenous base? At the moment, I have adenine, uracil, and guanine. We are drawing this diagram to explain to someone this is how a RNA looks like. So the reason I have adenine here, uracil here, and cytosine here, guanine here, is to inform the person looking at this diagram, all of this can be in the RNA. But if I want a better diagram, I didn't draw 4, then it becomes too small. So I'm just drawing 3 here. But if I want a better diagram, I need to have 4 nucleotides. The last nucleotide must have what nitrogenous base to make this a better diagram for RNA. Just give me the symbol enough. If I draw one more at the bottom here, what should be the nitrogenous base to make it a better diagram? Yes, Vishnu, Pavitrashni, Sharini, Lim Zingheng, Narmada. Anyone else? What should be? Okay, Keshava. Okay, Velmugil. Okay. All of you correct. So if you're drawing one more, then add in cytosine. So that makes it a better answer because I'm showing adenine, uracil, guanine, and cytosine. That will be better. But it's not a must. If you're drawing a nucleotide, a polynucleotide, you actually can just draw 2 also consider enough for it. 2 also enough, but normally, just to make it better, we draw 3. But I have another question for you. If, let's say, I made all of them cytosine, cytosine, cytosine. At the moment, I have guanine, at the moment, I have adenine, uracil, guanine. What if I made all of them uracil, uracil, uracil? Can or cannot? Can or cannot? If I draw, all of them have uracil. Accepted, not accepted? Can or cannot? Boleh ke tak boleh? Semuanya uracil. Can or cannot? Write the answer in the chat panel. Can or cannot? Yes or no? Write in the chat panel. You have a mixture of answers. Some of you say can, some of you say cannot. The answer is can. Can. Because we are drawing this to explain the RNA to another, I'm drawing this to explain to you. I make it a point to show all the possible. If you have one more with cytosine, even better. So in case in exam you need to draw, try to have different nitrogenous bases. But in real life, what's in here is supposed to be random. Supposed to be random. If you have all of them adenine, correct. If you have all of them uracil, correct. If you have all of them guanine, correct. What is in here? That depends on the code. Maybe the code, all of them same, we don't know. So what's in here is random. But the rule is, if you're drawing RNA, you cannot have timing. That's the only rule. You want to draw 3 uracil, 3 adenine, 3 guanine, your choice. Timing cannot have. That's the rule. So can, because this is a code. What's in the code depends on the code. I mean, what is the nitrogenous base? It can be any one of them, as long as it's not timing. So this is RNA. RNA is single chain, satu rantai. So if you're drawing, that's how you draw the RNA, but it looks something like this. This is a single chain, And if I zoom in, all of these colors that you see, the yellow color, the pink color, the purple color, and the blue color represents the 4 nitrogenous bases, the 4 types of nitrogenous bases. RNA is one polynucleotide. It is single chain. DNA is supposed to be double chain. So RNA is single chain. DNA is supposed to be double chain. And if I were to trace, trace, this is one chain, one helix. This is a different chain. So inside DNA, there is 2 helix. That is why we call DNA as double helix. DNA is double helix. RNA we rarely call single helix. We just call it single chain because normally it's just one long chain. But DNA, this is one helix. This is the other helix. So it's double helix. The name RNA is double helix. DNA is double helix. Drawing RNA, not a problem. Meaning we rarely ask you to draw RNA. I don't remember any past year question asking you to draw RNA because it's considered easy. The hard one is DNA. DNA is what they'll ask you to draw. So example, this one here, this is a character from, I think, okay. So this is just supposed to be a science joke. RNA is always single, whereas DNA is always double. Or if you watch the movie Game of Thrones, for some reason, this character, on one side she has a RNA, on another side she has a DNA. Is some queen or something like that in Game of Thrones, if I'm not mistaken. Okay, now let's draw DNA. DNA is double chain. So on one side, we must use deoxyribonucleotide. Must use deoxyribonucleotide. If I have many deoxyribonucleotide, this is one deoxyribonucleotide. If I have many, same like the RNA, we just link them up, you get one chain. There should be another chain this side. At the moment, single chain. But how am I showing the examiner that this is a DNA? Let's say this label don't have. But you look at this, you must know this is a DNA. What was the clue that this is a DNA? What is the clue that this is DNA? Yes, Vishnu, Lim, Charini, Narmada, Tanusha, Piratish, Kishantini, Abhishek. Okay, very good. All of you understand. Mine is still fresh. Timing. So we make it a point to have at least one timing. You want to draw all timing also can. But as I mentioned, when we draw, we are explaining to someone, we show all the possibilities. But if you draw all three timing, okay, the rule is cannot have uracil. This is one chain. DNA is double chain, meaning I need to draw one more chain this side, and this is where the problem is. The other side, the chain is in opposite direction. Now, how do you identify the direction? You look at the where this pentose sugar is pointing. It's basically pointing upwards. So you can say this as the DNA, that is the chain that is facing upwards. This side, we need to draw the pentose sugar facing downwards. It must go in opposite direction. The two chains, one upwards, one downwards. So when we draw the other chain, this is how it's supposed to look like. This is upwards based on the pentose sugar. This one is pointing down, so this is downwards. Now you can see the pairing of nitrogenous bases. Nitrogenous bases always form a pair. A must pair with T, G must pair with C. That is why they had unique shape that I'll show you after this. At the moment, A must pair with thymine, T must pair with A, and G must pair with C. This chain is facing downwards. So, DNA consists of two polynucleotide chain. 1, 2. Two polynucleotide chain arranged in opposite direction. Two polynucleotide chain arranged in opposite direction. That's one mark. So, when you have two chain, this pin no need to be upside down. Actually, I just took this picture, I copy paste here. So when you draw this in exam, just write the P. Actually, the P is not compulsory also. Without the P, you didn't label the P also, understood that's the phosphate group. If you want to add it, the thing is, you add one, you must label all. You add one P, all must have P. If you didn't have a P, you just have a circle, is also correct. Also correct. This one must have. All of this must have. But the P is actually optional. You have okay, you don't have also okay. Understood is the phosphate group. One of the students asked, this one must you draw upside down? Actually, I copy paste, I rotate the picture. That's why it's P like that. Maybe later I'll make it a normal P. At the moment, this is one chain, this is another chain, two chain. These two chains must remain together. They shouldn't separate. So to make sure they remain together, they must be holding hands. The holding hands happens in here. This is what you call nitrogenous base pair. When they are side by side, they form hydrogen bond. By forming hydrogen bond, the two chains will remain together, like they're almost holding hand. They remain together, they don't separate. The two chains are held together, dipegang bersama oleh ikatan hydrogen. Held together by hydrogen bond. Where does the hydrogen bond forms? Between nitrogenous base pair. Now this is two polynucleotide chain, opposite direction. This is going to hold them together, the hydrogen bond. This is the one that provides the support for the DNA. Like your body, we can stand because our body has support. The support is the skeleton, the bone. To make sure we can stand, at the back we have backbone. The backbone provides us support. Because we have backbone, we can walk, we can run, we can stand. You learn later, chapter 14. The backbone gives us support strength. What provides support for the DNA? Also backbone. Where is the backbone? This is the backbone. In the backbone, they have what? Pentose sugar, phosphate group. Phosphate group, pentose sugar. This is the backbone of the DNA. Nitrogenous base pair will have hydrogen bond. A and T, two hydrogen bond. G and C, three hydrogen bond. This one will have three hydrogen bond. I'll show you another picture later. At the moment, this is holding them together so that they don't separate. To provide support, this is the backbone. The backbone is called as sugar phosphate backbone. Sugar phosphate. That is the backbone. Both sides. This is backbone. This is also the backbone. Both sides providing the strength is the backbone. Holding them together is the hydrogen bond between complementary base pair. Complementary base pair RNA don't have because they are single chain. Double chain will have complementary base pair. Hold them together. That is why in form 6, we draw like this. Adenine is pointed, thymine pointed inwards. They form one pair. Adenine and thymine, two hydrogen bond. Guanine and cytosine will have different shape. This is round inwards. So meaning you can't take thymine attached here. You can't take adenine attached here. We are showing A must be with T, G must be with C. G and C is three hydrogen bond. I repeat, this kind of shapes is for Form 6 A level matriculation. Your level, you just draw both of them. You just draw them, both of them, same size. Guanine, cytosine, rectangle enough. This one, specific shape, is for higher level. If you want to draw, can be now, but no need lah. Just draw a rectangle is fine. Problem is, uracil doesn't have a pair. Uracil is always single because they're only found in RNA. They normally don't meet. But by right, uracil's boyfriend should be whom? Uracil's boyfriend should be whom? Let me clear my nose. In the meantime, uracil boyfriend should be whom? If you think logically, who is the boyfriend of uracil? It should pair with which one? should fit with which one? At the moment, no pair. But based on the shape, it is able to pair with someone. One of it, which one? Based on the shape, you can know already. This one pointed inward. That means you can actually draw an adenine here. This is adenine. Pointed inwards, pointed inwards. So you supposed to pair with adenine. So this is the husband. This is the official wife. This one is the girlfriend, unofficial girlfriend. On and off they'll meet. How to remember this? One technique you can use is aku tak guna kondom. Aku tak guna kondom. Use that to remember AT, because A must pair with T, G must pair with C. So you can just use the word aku tak guna kondom to remember the sequence AT, G, C. Whereas U doesn't have a pair. But if they meet, they can pair with adenine, something like this lah. So this is the secret relationship between adenine and also uracil. Officially, they are with thymine, but whenever they meet uracil, they can meet. If they meet, they can form a temporary bond. Permanent bond is with thymine. Even in DNA also got this kind of a thing. Okay. Someone asked me earlier, one of the students asked, you want to have the RNA picture. Actually, by right, the picture is already in your notes. This is just colorful, but by right, RNA picture. RNA, you don't have to draw. Can anyone tell me why you don't have to draw RNA? Logically, why you no need to draw RNA in exam? What's the logic? We don't ask you to draw RNA. Why? What's the logic behind it? Kenapa kita tak tanya pun? DNA already have. Abhishek already kita. DNA already have 2 RNA technically. So why should I ask you RNA when I can ask you DNA? By drawing, if you can draw a DNA, that means you can draw RNA. And another thing is why we love DNA, because we can confuse you. DNA is double chain. Asking you to draw this whole chain, it's a bit, limited time during exam. Drawings, maximum they give you 3 marks, not more than that. However complex the diagram is, maximum marks for drawing is 3 marks, not more than that. Even 3 is a lot. Most of the time they give only 2 marks, sometimes 3, not more than that. To get 3 marks, you can't be spending 15 minutes, 20 minutes drawing the diagram. End of the day, you're only going to get 3 marks. So they need to make sure you can complete the diagram within 5 to 10 minutes. If I ask you to draw this whole thing, you're going to take 15-20 minutes. It's not easy to draw the whole thing. So exam time, what we do? We give you the left side. Ini kita bagi. Yang ini kosong. That means the diagram will be something like this. Okay, I don't have it. They give you the diagram. They have only this part. This part here not given. They ask you to draw. So in the structure question, what they do, they give you the left side, the right side, they leave it empty. They'll make a statement. This is an incomplete diagram of DNA. Complete the diagram. They give you 3 marks. Most of the students don't even know how a DNA looks like. So what they do, they just draw back the same thing. Students who don't know the concept will take this, draw in here. They draw back the same thing this time because they don't know. Some students draw this, but the pentagon they draw facing up. We give you 3 marks. What is the 3 mark? Point number 1, this must be facing down. You get 1 mark for that. Point number 2, you must show complementary base pair. You have complementary base pair, another 1 mark. You must show the hydrogen bond. Adenine, thymine 2, guanine, cytosine 3. That's the 3 marks. Whenever DNA comes out as exam question, structure question, If they ask you to draw, we always give you the left side. You need to draw the right side. Make sure it's facing down. Make sure you have the pairs. Make sure you have the number of hydrogen bond. That's your 3 marks. After this, we'll draw our DNA. So at the moment, this is how a DNA looks like. Holding them together, hydrogen bond. Supporting the DNA, sugar phosphate backbone. Both sides, left and right, have sugar phosphate backbone. This is how a DNA looks like. This is complementary base pair. Complementary is with the E. Sometimes students write COMPLI. Compliment is what you do, when you praise someone. You're looking handsome today. You're looking beautiful today. You compliment someone. Your help is much appreciated. You compliment. That is PLI. PLE means sepadan. It's a pair. They complement one another. Husband and wife complement one another. The word boyfriend, girlfriend complement one another. PLE. So PLE is for complementary base pair. At the same time, nitrogenous base pair, as I told you, adenine must go with thymine, 2 hydrogen bond. Guanine cytosine will have 3 hydrogen bond. Most of the time, uracil is single, doesn't have a pair. But if it meets adenine, it can actually form a bond. But officially, adenine should be with thymine. If in case they meet, then adenine can pair with uracil. Okay, actually, this picture other way around, because I was explaining to you one husband. This is the husband, and then he has one official wife and also unofficial girlfriend. Here, terbalik. The girl actually, the wife has official husband and unofficial boyfriend in this picture. Anyway, you understand the concept? Done. So, we are done with DNA. What we need to do now is we need to draw the DNA. So, drawing the DNA, I've already drawn for another class. I'm not going to underline all of this because all of this already explained. You should be able to understand all of this. Semua ini sudah diterangkan, nicely written for you. This is how a phosphate group looks like. Already draw and label. If you're drawing one nucleotide, label the P. This P here, label. If you're drawing one nucleotide. But if you're drawing DNA or RNA, if you didn't have the P, never mind. You want to add it in, you don't want to add in also, doesn't matter. But if it's one nucleotide, you need to add. Yes. Okay. Okay, now this is RNA. How do I know it's RNA? Because they have uracil. So this must be RNA, and you have all the explain. I haven't explained to you different types of RNA. There is 3 different types of RNA. What you see in here, I haven't explained that one later. At the moment, this is how you draw an DNA. So RNA is single chain. This is RNA. If you're drawing single chain, I should have a diagram for DNA. Yeah, this is for DNA. So this is double helix. Erase all of this. Okay, we'll come back to all of this explanation here. What we need to do now is we need to draw the diagram. This is what you need to draw. This is what you need to draw. And here you can see the student asked me whether I need to make it P upside down. You can just label like this, okay. Actually, the P here is optional. Lukis boleh, tak lukis pun tak apa. Okay, so this is the drawing that I already draw. And as usual, when I draw a diagram, I try to use the diagram as a summary for what we have explained. So this is what we need to draw now. So I'll draw with you. The 3 marks for the DNA. The DNA diagram will be 3 marks. They will only give you the red one. The green one you must draw on your own in the actual exam. Now you must draw both. Normally in the exam, the red is given, the green one, left side is given, the right side is the one you need to draw. When you draw, the 3 marks is for this. Direction facing down, the complementary base pair, and the number of hydrogen bond. That's why you get the 3 marks. So what we need to do now is we need to redraw the diagram. So maybe I draw this side. Okay. Now you can follow. You can see how I'm doing it, and then later you can draw on your own. Diagrams, whatever that can come out as exam question, I'll draw. Not all the diagrams I draw. Whichever can be asked as an exam question, we draw. DNA can be an exam question. Nucleotide can be an exam question. So you must know how to draw. So first step. Okay, now to make sure our DNA is straight. To make sure our DNA is straight, what we can do is we can first draw a line, a faint line. Use pencil, draw a faint line. Later you're going to erase it. So what I do is I first draw brown color. I draw a circle to represent the phosphate group. From that circle, I just have a line slanted. I use this line to form the pentose sugar. And here is the nitrogenous base. So this is one nucleotide. I can do the same thing. I just go a bit down, and then I can draw one more circle. And just go a bit down and then draw another circle and repeat. To save time, what I'm going to do, I'm just going to copy paste this. You just have to repeat it 3 times. Bring up. Okay, when you have 3 in a row, make sure the link is from here. The link is from here, because some students make mistake. They put the link here. This is wrong. You cannot come from the same point. It must come from the one at the bottom. So this is where the link is. This is where the link is. So drawing this is generally not a problem. Let me just make this a bit smaller. Drawing this by right shouldn't be a problem. But this is normally already provided during the exam. So you just need to draw the other side. So now what I need to do is to make sure the other side is also straight. I'm going to draw another line on this side. So let's say there's a line here. So this one, I don't need it anymore. I can remove it. The other side, the best way to do it is, I'm going to use a different color. So we draw the nitrogenous base first. We draw the rectangle. We draw a small line. And then we draw the pentose sugar. Make sure the pentose sugar is facing a bit hard. Actually, you can do something that I cannot do, which is you can just rotate your paper. I cannot rotate my paper. So at the moment, it's like this. So this is the pentose sugar. So I have one. I repeat, you can just rotate your paper. I cannot rotate my paper. And you just do 3 like this. You can start to draw actually. So this is the first one, this is the second one, and this is the third one. So we now have 3 in a row. Here also always students make mistake. You don't link them here, you link them here. This is the place it links, not here. This is where it's supposed to link. So that means there is one link here. There is another link here. Now I can zoom in here. I randomly choose adenine. I randomly choose guanine. I make sure I have one adenine, one guanine. The third one is random. Maybe I use thymine. So the pair C must be with A, G must be with C. C and A must have 2 hydrogen bond. G and C must have 3 hydrogen bond. G and C must have 1, 2, 3. 3 hydrogen bond. A and T must have 2 hydrogen bond. Okay, our DNA is almost done. So meaning I can remove this line. Just use a pencil and make it a faint one so that our DNA is straight. If not, your DNA is going to be crooked. It's going to go one side. So this is how the DNA looks like. Oh, 11. Our class finished 11:30. Oh, I don't even realize the time. Okay. Now draw this first. Draw this first. Okay. As I mentioned, if you have something like this, they might minus mark because you see the line is not complete. So don't have gaps like this. Make sure it's a complete line. Some examiners fussy, they see this, they sometimes don't give you the mark. So this is one DNA at the moment. I repeat, exam time. Oh, okay. We start at 10. Okay, sorry. Okay, I thought we start at 10 o'clock. We start at 10:30, 12 o'clock again. And then got time to draw. Okay. At the moment, this is the DNA. As I mentioned earlier, normally the green one is the one you need to draw. The brown one is normally given in the exam. When you draw, what the examiner wants to see, do you have this spacing down? Do you have the pairs? Do you have the hydrogen bond? That's your 3 marks. Now, the diagram is complete. I'm going to label this diagram. In the meantime, you can start to draw. I'm going to label this diagram. I'm going to draw this, already draw. Now I need to label. The phosphate group is optional. You want to label the phosphate group, okay. If you didn't label, okay. Now I'm going to label this diagram. So the first one I'm going to label is this. This is the monomer. So the monomer is deoxyribonucleotide. This is the monomer. You can start to draw. I'm just labeling the diagram. Okay, so this is deoxyribonucleotide, monomer of DNA. The monomer. Okay, this one is the complementary base pair. Okay, so we have complementary nitrogenous base pair. We have deoxyribonucleotide, which is a monomer. Now this part here is the backbone. Finding it a bit hard to fit in this whole thing. Okay. Draw and label. Once you're done, raise your hand. Okay. By right, I can still label some more. I repeat, exam time, this will be given. What you need to draw is what's on the other side, because we know that's the one students normally don't know how to do. Facing down, complementary base pair, the number of hydrogen bonds. Okay, so this is how the DNA should look like. At the moment, go to the next explanation. So actually, RNA, DNA done. In terms of structure done, after this is the function. The function is the complicated one, but structure-wise, DNA, RNA done. Most of the time, if the question comes out also, they'll only ask the structure. The function is there in the textbook. I'll explain. It's quite complicated. But for the moment, structure of RNA, structure of DNA done. We'll do a question after this. We compare and contrast DNA and RNA, which is normally the question for exam. Before that, complete this diagram. Once you're done, we'll go to the next explanation. Now I've lowered all of your hands. If you're done, you can raise back. Yes, I agree. It's not an easy diagram, but this is what you have in the syllabus. If it's in the textbook, it can be and have been exam question. Draw DNA, complete the diagram. Must put the box. No. All of these labels is, in class, I always, that if we are drawing the DNA, I'll try to use I love to understand using diagram. So earlier I showed you the presentation, all the information you need to know. So all of that information, if possible, I add it into this diagram. So when you look at this diagram, it's not only you know how to draw, you also get all the important points that you need to know about DNA. Like the definition of DNA is that the monomer is there, the backbone is there. All of that is what you have in the notes. So you have an option of reading the notes or understanding the diagram, as long as you understand. Some students like to read. Some of us, like me, I like to understand using diagram. So when I draw a diagram, I try to add in all the information inside. Whichever can be added in, I'll add it inside. Actual exam, you just draw the green one enough. The red one's all on it. Unless they ask you to label. If they ask you to label, they must give you more marks. Drawing on its own already 3. Drawing already 3 marks. In case they ask you to label, for every label, they must give you marks also. Is that okay? The student asked me the question. Student asked me the question, sir, must put the box during the exam. I was explaining about that. Okay, I'm still waiting for Narmada, Piratish, Sharini and Vishnu. We can't go into the function because we already at 11:30. So we can't go into the function. What we'll do is we'll answer a question, compare and contrast DNA and RNA. Compare and contrast DNA and RNA. Vishnu done? Okay, thank you. Okay. Now, this is how you draw. Okay, under this, what we do, we are going to compare. Okay, I'll just put a note here. Okay, if there is a question asking you to draw DNA or RNA, basically the 3 things we want to see. The 3 marks is number 1, direction of DNA. Make sure you have one upwards and downwards. The second one is make sure you show the complementary base pairs. And number 3 is number of hydrogen bond. This is where you get the 3 marks. So make sure you provide these 3 in case they ask you to complete the diagram. Show the direction, show the base pair, show the number of hydrogen bond. Okay, now exam question, what we can ask you. So the exam question, what we can ask you is compare and contrast DNA and RNA. Let's say the question gives you 3 marks. Compare and contrast. Compare and contrast means similarities and differences. Okay, now, anytime you have a question related to compare and contrast DNA and RNA, just think of these 3. Polynucleotide. Okay, even before polynucleotide. First is monomer. Second is polynucleotide. And number 3 is nitrogenous base. Think of these 3. If the question asks you to compare and contrast DNA and RNA, think of these 3. Just change it into. So compare and contrast DNA and RNA, think of these 3. So the first one should be monomer. So in terms of similarities, okay, similarities number 1 should be based on the monomer. So similarity number 1. Monomer for both is nucleotide. Similarity. Number 2, polynucleotide. Both consist of polynucleotide chain. Number 3, nitrogenous base. These are the 3 similarities. Monomer for both is nucleotide. Both consist of polynucleotide chain. Both has nitrogenous bases, adenine, guanine, and cytosine. Adenine, guanine, cytosine, both will have. These are the similarities. In terms of differences, we use different color. Let's say I'm using green. Okay, in terms of differences, we use the same thing again. Monomer. That's this. I mean, comparing DNA and RNA. Compare and contrast. I'm in class. Where are you? Okay, okay. After the class, I'll come. Okay. That means DNA and RNA compare and contrast. They ask you similarity, you use this. They ask you for difference, also use this. So in terms of differences, monomer. So the first difference is about monomer. Okay, what I can do is I can just draw a line here to make sure everything is straight. Just to make it presentable. And this is the problem if you are a perfectionist. So I come under a group known as perfectionist. Everything must be in order. Not in order means we don't like. Okay, differences. So differences. Monomer for RNA is ribonucleotide. For DNA is deoxyribonucleotide. Okay. First difference. This is ribo. This is deoxyribo. The trick is understand this. From here you get that they'll normally ask you for similarities or differences. Both answer is here. So second difference. Second difference is polynucleotide. The number of chains. RNA consists of single polynucleotide chain while DNA consists of 2 polynucleotide chains. Nothing much. All of these you already know. Just that you have to know how to put it into proper sentence. And the last difference is nitrogenous base. Only RNA contains I've completed similarities and differences. I got 6 marks by just remembering monomer, polynucleotide, nitrogenous bases. Yes, there are other differences. There are other differences. But most of the time, They need only 2 or 3 differences, 2 or 3 similarities. Cover this. The others, there is a lot of other difference. Like for example, function of DNA different, function of RNA different. How many types of DNA, how many types of RNA is different. Where are they found is different, but I consider all of them extra. This is the one you must know because this is the basic information. Monomer, polynucleotide, nitrogenous base. So this is the 3 similarities. These are the 3 differences. So the role of this line is done. We can remove it. So I can make it like this, then it's too small. But at the moment, I'll show you this is the differences. These are the differences. These are the similarities. By right, there are other differences. There are other similarities. Okay, once you are done for this, once you already copy this, raise your hand. Okay, finish it. Huh? Once you finish copying, raise your hand. You must have the word while because it's a difference, so you must have the word while. Without that, cannot. Narmada, done? Okay. Now, just showing you the notes before we end the class. This is DNA, this is RNA. So by right, almost all of these already covered, just highlighting to you. RNA is single polynucleotide. Even before this, we have this general, all of this general information I already covered. Now we have RNA is single polynucleotide chain. They have adenine, guanine, cytosine, and uracil. The 3 types, next week you will learn. And okay, the rest of this next week. This is for DNA. DNA, most of it you already learned. 2 polynucleotide chain arranged in opposite direction in double helix shape. This is double helix. Okay, they are held together. The 2 chains are held together by hydrogen bond that forms between complementary nitrogenous base pair. Adenine is paired with thymine. They have 2 hydrogen bond. Guanine is paired with cytosine and it has 3 hydrogen bond. And after that, yeah, we are okay, done. Meaning at the moment structure finished. There is explanation in your textbook in terms of the function. The function of the DNA and RNA is the function of the DNA and RNA is quite a complex explanation. So we need to spend at least around 30 minutes explaining the function. Once you already understand the function, then you will understand why RNA there is 3 types. The names all I'll give you in the next class. But as of for now, structure of RNA, structure of DNA, drawing of RNA, drawing of DNA, compare and contrast RNA and DNA already done. So that luckily, blessing in disguise also, because if I explained all of this yesterday, it's right in the evening after school, tiring. Hopefully today you're fresh, a bit easy for you to absorb all of this information. We have one more complex explanation, the function of DNA and RNA. Once we are done with that, we can start with chapter 5. Technically, chapter 4 done, just a bit more to go. Next week, we finish that, we start with chapter 5. Any questions? If you have question, you can ask. If no question, thanks for coming. Enjoy your holiday. See you again next week.